Assalamualaikum and good morning. For today's talk, it is about analysis of mounting bracket. There are three main criteria that should be fulfilled through linear static analysis. The structure must be metallic material, and also the structure should be support load of 300 Newton without presenting plastic deformation or fracture. In designing the structure, we must consider the mass must be lower than 0.7 kilogram, and also factor of safety, it is equal to or greater than 2.0, and maximum deformation is lower than or equal to 0.8 millimeter. After all criteria have been achieved, we have to perform two additional analysis, which is thermal stress analysis and free vibration analysis. For our first design, it doesn't fulfill the design criteria at the loading area because it is too small. For the second design, it is also doesn't fulfill the criteria because through linear analysis, we can see the result, it is too much deformation. This is our third design. It's quite bulky and big. Because of that, it is too heavy. For the final design, with this design, we achieve all the criteria that needed. By that final design, we updated it by removing 10% of the mass, but still achieve factor of safety greater than 2.0 and maximum deformation is still lower than 0.8. The material is titanium.
Okay, next, after we had done redraw a new design of mounting brackets in CATIA software, for the next step is we need to do an analysis using ANSYS software. There are three types of ANSYS needed. First is linear static analysis, second is thermal stress analysis, and third is free vibration analysis. For the first step, we need to open the ANSYS software and identify material selection that we have been used. For example, titanium metal choose be as material selection in our design, and we need to select linear static elasticity for linear static analysis. For the second step is we need to insert all the engineering data about the material. Insert all the data, include its strength, Poisson ratio, Young modulus, ACT, shear modulus, and create the matrix assignment for titanium alloy. For information, titanium are metal with a lightweight material and have high strength and durability properties. So this is why we choose titanium alloy as our material selection for our design. In the table above, Young modulus for titanium are 119 GPa and the Poisson ratio set up at 0.37 follow the mechanical and physical property of titanium alloy. The density of titanium material is 4.512, the power of 6 kg per meter cube. The isentropic coefficient of thermal expansion is 9.1, the power of 6 Kelvin, and the shear modulus of material properties is 4.3431, the power of 10 Pascal. After that, we need to create a material assignment on the body titanium alloy. Click on the body until it turns into the green color as marked selected body for the full body of assembly, and then click on the body until it turns red color as marked as it be done. For the third step is apply boundary condition, which is identify which surface include in fixed support as a boundary conditions. Select all the 8 face body as a fixed support types and click apply to selected body. For example, in our designs, the hole at the back are be a main fixed support in our design. And next, after we had done apply boundary condition for our design, we need to apply loading condition in this situation, which is determine the load direction, amount and critical pressure applied and the location of the loadings. For example, in our task project, we need to support 300 Newton of load in our design that without presenting plastic deformation and fracture pattern when we analyze using ANSYS software. Select all the inner two face body as convection types and magnitude 300 Newton as a load that is shown above, and then click apply to the selected body until it turns red. The direction of the force load is downsides is a z-axis position, and the surface effect was applied. For the next step is mesh properties, which is we need to set up mesh touch element and mesh condition. In our project, mesh condition are tetrahedron condition and count the number of node and element number. Element size was set up as 3.0 meter, and the nodes elements and was less than 120,000. Follow the instruction given. So our mesh are less than the limitation of the task. So the requirement of the project task is successfully achieved in our design and structure. For contact properties, in the step 6 is identify the contact surface if it has two elements in analysis and sets bonded if necessary. So in our designs, there are only one type of element. So they have no contact properties and bonded condition. And last, for the last step is solve the analysis. Solve analysis for total deformation and equivalent stress if the step had done, and make sure each step has green tick symbol in the software. Oh, okay, next. For thermal stress analysis, we repeat the same step as follow the linear static analysis. In thermal stress analysis, we need to create thermal condition load condition, apply on the assembly parts. And next, select all the outside one body as a thermal condition types and magnitude as a final temperature is 15 degrees C as shown above. And then click apply to the selected body. The initial temperature of the thermal conditions load is 25 degrees Celsius. And the mesh properties also will be the same. And for the last step is solve the analysis, solving analysis and find the total deformations and the equivalent stress in thermal stress analysis of our project. And the last step is free vibration analysis. For the first step, we need to create model analysis system and then apply to the assembly parts. Select all the engineering data, properties, material in the data properties. We repeat the same step for identify material selection as a titanium metal. And the second step, insert engineering data about the material, insert all the data, its strength, position ratio, modulus, density, shear modulus, and create the material assignments. And the third step is apply model conditions. In these conditions, we need to identify which surface include in the fixed support as a boundary condition. Solve the analysis. Solve analysis for total deformations of deformation 1 until deformation 6.
Today I will present about the linear static analysis for the result and the discussion. In this project, the mass that we got is 0.294 kilogram, and the FOS we got the 11.871, and for the deflection we got the 0.27384 millimeter. And we show that the calculation of factor of safety and the percentage of mass, FOS, and deflection that we got in this project. In this project, the mounting bracket project, the FOS that we got 11.871 is significant higher than the target value of 2.0. That means that the structure has a very high margin of safety and is very unlikely to fail under the activated load. This is a good thing as ensure that the structure is safe and reliability. The material selection of this mounting bracket is also play a role in the result obtained. That we choose the titanium. It has a lower Young modulus than the other material, which means it's more prone to deformation under the same level of stress. For the thermal stress analysis, we got the two different type of result, that with temperature effect and without temperature effect. Firstly, we got the equivalent stress is 95.701 megapascal, and without temperature effect we got the 88.976 megapascal, and for the total deformation we got the 0.28634 millimeter, and without the temperature effect we got the 0.27363 millimeter. Okay, next is the difference in result due to the temperature effect can attribute to variation in material properties, including thermal expansion and non-linear behavior, as well as the influence of the boundary condition and the thermal constraints. Accurately considering this factor and analysis is necessary to ensure the accuracy and reliability of this result. The equivalent stress and total deformation of bracket tend to increase. This is because the coefficient of thermal expansion of titanium is higher than the other metals such as steel. That means the titanium is spent more exposed to the same temperature exchange. As a result, the potential for deformation and stress in bracket also the higher. Also, the titanium, the result of the linear static analysis indicate the value stress total deformation increased by 10% and 5% respectively with temperature increased by 100 Celsius. This suggests that the bracket is susceptible to the deformation and stress when exposed to the high temperature. Okay, next is the free vibration. We can see all the mode total deformation for the each mode and the natural frequency that we achieve in this project. In this project of titanium, the natural frequency is higher than the other material due to the high modulus of elastic. That means that titanium bracket are more resistant to deformation that can withstand higher load. Additionally, titanium is lightweight material, so the titanium bracket can be smaller than bracket made of the other material while providing the same stiffness and performance. As we can see in the mode 1, the natural frequency is 4.3013 exponent 6 Hz. That means that structure will experience maximum displacement and deformation. And at this frequency, the load that much this frequency will result the critical response from the structure.
Okay, hello, my name is MUTTAQIN IDRUS. Let me continue our presentation with the conclusion of the analysis of mounting bracket. As a conclusion, linear static analysis is a useful method in structural engineering and related for everything how a structure responds to applied loads. It also provides valuable insights into factors like maximum stress level, and overall deformation, aiding in design choices and ensuring structural integrity. Not only that, the linear static analysis also provides significant findings for the project and delivering essential information on the structure behavior, stress distribution, and also the deformation under the applied loads. This finding can guide further design decision and ensure that the design meet the criteria desired. And the factors that can be impact the result are such as input parameter used, the modeling and simulation technique employed, assumption and simplification made, material behavior, consideration, numerical error and convergence, boundary condition, and also last but not least, constraint. These factors should be carefully considered and addressed to ensure the accurate and reliable result. Sensitivity analysis and validation studies can further enhance confidence in obtaining the best result. So that's all from our conclusion. Thank you.